Okay, so we're going to draw our basic sine graphs and basic cos graphs from our unit circle because it gives us all of our x values, which are the degrees and the radians, and all of our y values, which are the outside. Correct? Remember, how do I know? Whenever you put an input and get an output, you have a coordinate. We agree? Yeah. So when I said sine of 0, you would tell me what? It equals sine of 0 equals 0. Sine of 0 equals 0. Go on your formula sheet, right? Sine of 0 is at 0 degrees, 0 radians. What's my sine value? It's 0. It's the y value, correct? What's sine at 180? At 0. What's sine at 270? -1. So I'm getting an input and an output coordinate. Input and output coordinate. Input, output coordinate. Correct? Okay, what's sine at 135? Yes, you do. Go to 135. Root 2 over 2. Do you agree?
Yes.
Okay. What's sine at 225? What's sine at 225? Negative root 2 over 2. Yes. Okay, so I just pulled a whole bunch of coordinates off of there, correct? If I take each one of those inputs and outputs, draw a coordinate, I would have a graph, would I not? Okay, let's look at this. So, the inputs for sine are the inside of the circle, the zeros and the degrees and the radians. The outputs are the y values, technically. But for cos, my inputs are my inside, but my outputs are actually the x values, correct? If I wanted to do tan, I would do the inside values would be my x values, and then I have to take every y divided by x, get my output. Y divided by x, get my output. Y divided by x, get my output, draw. Correct? So your output is the x's, the y's, the whatevers on the outside. So let's draw a sine graph. So you guys told me at 0, I want this. Okay, at 0 you told me, we're doing radians because it's in radians, you see that? At 0 it was 0. So I can go to 0 radians and I get 0. Now, we're going to go over one other thing. How the heck do we label an x-axis when it's in radians? If you follow this method every single time, life will be easy. Okay, ready? Count how many ticks it takes you to get to pi. So, 1, 2, 3, 4, 5, 6, correct? It takes 6 ticks to cut, it cuts into 6 ticks to get you to pi, correct? So this first one would be 1 pi divided by 6. Then this would be 2 pi divided by 6. Pi over 3. And then this would be 3 pi divided by 6, which reduces to pi over 2. Then this would be 4 pi divided by 6, 2 pi over 3. Then this would be 5 pi divided by 6, which doesn't reduce. Then this would be 6 pi divided by 6, which is pi. This would be 7 pi divided by 6, which doesn't reduce. This would be 8 pi divided by 6, which is 4 pi over 3. This would be 9 pi divided by 6, which is 3 pi over 2. 10 pi divided by 6, 10, which would be 5 pi over 3. And then this would be 11 pi divided by 6. And then this would be 12 pi divided by 6, which is 2 pi, right? So as long as you count the amount of ticks, you could label for life. And then you could label this way, negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative. Going that way. I'm going my negative, not your negative. Yeah? Okay, let's label stuff that we have. So we have 0, 0. Then we have pi over 6. What is my sign? It's Virgo, because I'm a September baby, but that's okay. What is the actual sign for this? That was funny. No one laughed. All right, I'll be
We're so focused on that. I don't understand.
My sign, like zodiac, is Virgo, because I'm born in September.
It's those things you see online, like, oh yes, you were born in.
No, like I'm born in September 8th, so I'm a Virgo in a zodiac. It's called my sign, but this is the sign. I was just joking. Catch it? Yeah. Play on words. Yeah. Okay. Okay. Pi over 6. Pi over 6. What sign? So I'm going to label these as 0.5 and 1, negative 0.5 and negative 1. Why do I do that? Because the radius is positive 1 and negative 1. I'm not going to get any higher than that, correct? On a basic sine graph. So I'm at pi over 6.5. Then I'm at pi over 3, bless you. and root 3 over 2, which is 0.866, blah, blah, blah. So I'm going to round that to about here. Then pi over 2 is at what? 1. Then 2 pi over 3 brings me back down to root 3 over 2. I'm just pulling the y values off at those spots, right? Because sine is all the y values. So at 2 pi over 3, I'm at 0.866 here. And then at 5 pi over 6, I'm back down to what? What's the y value at 5 pi over 6? 1/2. Then at pi, I'm at 0 again. Then at 7 pi over 6, I'm at -1/2. 4 pi over 3, what am I at? I ran out of tables, so I'm just going to drop. -0.866. At 3 pi over 2, I'm at -1. At 5 pi over 3, I'm at -3 over 2. At 11 pi over 6, my y value is -1/2. And at 2 pi, my y value is 0. And look what I have. It's not peaked. Don't make these mountains or really pointy valleys. This is hard because I can't see where I'm going. My hand is covered. Yeah, you can draw arrows on the ends because it keeps going.
Do you have to?
Yeah.
Do it.
I thought I'd draw something real quick. Yeah.
Where do we get the y values from? Do we have the calculator in front of us, or?
No, the y value is on your unit circle. Because sine of 0 is the y, sine of, you know what I mean? All the y's. We're going to come back to this. We're going to come back to this. We're going to flip to the next page just quickly, and we'll come back to both of these, I promise. The next one is what? Wow, it really adjusted mine to a really stupid spot, but whatever. The next one is going to be coses. So my input is the center. My output is the x value this time. Because cos of whatever is the x value, we agree?
Yes.
Okay. Could I draw every single trig ratio off of that unit circle? Yeah, I could do tan at 0. I just have to do y divided by x. I could do cotan at 0. I just have to do x divided by y. I could do secant at 0. I would just have to take cos, yeah, and flip it. And I could do cosecant at 0. I just have to take sine and flip it. I could draw every single trig ratio off that unit circle. And it's periodic, so it's going to just keep doing the same thing over and over. Yeah?
There's not more than 6.
No. Okay, so at cos, what's 0 for cos? Yours is nicely beside mine, somehow it's up there. So 0.51, -0.5. So at 0, it's x is 1, correct? And then I have, pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 2 pi over 2, 5 pi over 3, 11 pi over 6. So I just didn't include the 45s, the pi's over 4s, 45 degree reference angles, but you could put them in there in between the pi over 6 and the pi over 3. They'd fall in there if you want to be more accurate. At pi over 6, what is my cos? Root 3 over 2, because we're just looking at the x values, right? So 0.866. And then at pi over 3, what is it? And then at pi over 2, my x is 0. 2 pi over 3, my x is 5 pi over 6, root 3 over 2. 3 pi over 2, or sorry, pi, is negative 1, right? 7 pi over 6, what's my x? Negative root 3 over 2. As you can see, it's do the same thing. 4 pi over 3 is negative a half. 3 pi over 2. What's my x at 3 pi over 2? 0. Cos of 5 pi over 3. It's a half. Cos at 11 pi over 6. What do we get at cos at 11 pi over 6? 26x. And then cos at 2 pi brings us back to 1. So we go from a max to a max on this one, right? In this short little space, it would actually look like a sine graph because it would keep, like it just goes mountain valley, mountain valley, mountain valley. And I'm reaching 1 and negative 1, 1 and negative 1, 1 and negative 1. We agree? So this one just starts at 0, 1. The other one actually starts like here. 0, 0 goes up a mountain down, up a mountain down. Okay? We'll go back to the sine graph. Okay, the period is the length of the interval over the domain which the graph repeats itself. So how long horizontally it takes till it's going to do it again, till it's going to repeat. So if we look at this graph up here, it's 2 pi, correct? Because it's going to start at 0, 0, it's going to go past a maximum, past a minimum, back to 0, 0, and then what's going to happen again? The same thing, over and over and over. So how long does that take horizontally? 2 pi. So the period of this one is 2 pi. The period of a sine graph, right? Okay. The other word, amplitude, is half the difference between the max and the min and the values of the periodic function. The amplitude is a distance. So it's half the distance from the maximum to the minimum. The amplitude, therefore, because it's a distance, is always positive. So you can use the formula max minus min divided by 2, absolute values. Why is it absolute values? Because the amplitude has to be positive, and if it was all below, it could end being negative or wherever, right? So in this case, it would be the absolute value of my maximum, which is 1, minus my minimum, which is negative 1, and then divided by 2, which is the absolute value of 2 divided by 2, which is 1. Now, does that make sense? Let's check. So, if I count up that amount and down that amount, I should meet the same spot because that's halfway, right? So if I count down 1, which is my amplitude, and I count up 1 from my minimum, what do they both reach? In this case, the x-axis, which we'll learn what that is later in the next lesson. But the amplitude is correct, right? So if you draw up your min, down your min, they should meet at the same spot because it should be half your distance, correct? So instead of using the formula, what could I do? I could go, okay, negative 1 to 0 is 1, 0 to 1 is 1, so that's a distance of 2, half of that is 1, so my amplitude is 1, right? Okay. So I know my amplitude is 1. My domain, it keeps going on for life. So what's my domain? XER. And the only way it isn't XER Inset notation or negative infinity to positive infinity, and interval notation is if I restrict it, which I was doing to you guys. Because if I don't restrict it, your answers, you're going to have to give me a general answer, a general term answer. Remember how we did general term for coterminals? We added 360 to get to the next one, to the next one, to the next one. So we added 360n NEI to the very first principal angle. We have to do that too for here, which we're going to do in a second for our x-intercept. What's our y-intercept on this graph? Our y-intercept? It's 0, 0, right? What's our range for this graph?
Y has to be greater than or equal to -1 plus
Yeah, so we do -1 is less than or equal to y, is less than or equal to 1, YER. Whenever we're sandwiched between two values, we go low to high, and they're both less than or equal to signs, because you read from the y. Y is greater than or equal to -1, y is less than or equal to 1. And in interval notation, square brackets in between. The theta intercepts, so the x-intercepts. And the reason why it's the theta intercepts is because the variable here is theta. So technically, I should have went theta ER. That's what I should have done. Where do the x-intercepts happen? Where do the theta intercepts happen? Yeah, the first one's at 0, the next one's at pi, the next one's at 2 pi, then it would be at 3 pi, 4 pi, 5 pi. If I went this way, what would it be? Negative pi, negative 2 pi, negative 3 pi. So we don't have a restricted domain here, right? So we're going to have to write it in general term. So how do we do that? We always start off with theta equals, because that's what our x is, our smallest principal angle. What's the first principal angle? It's technically 0. Right? So we'll write it, we won't write it after that, but we're going to write it. So we write our first one. So it's at 0. And then we have to add how much to get to the next one? Add pi, add pi, add pi, add pi. Or we're technically subtracting pi, subtracting pi, subtracting pi. Yeah.
What's principal angle?
Principal angle is your angle between 0 and 360. So the first one that happened here is 0. So we're adding pi n. And we're also subtracting pi, subtracting pi, subtracting pi. How do we cover adding pi's and subtracting pi's? We make n be an element of the integers. Because if it's an integer, if I put a -1 in here, I'm going to subtract pi. If I put a -2 in here, I'm going to subtract 2 pi. -3, subtract 2 pi. Now, this isn't wrong, and that would be marked correct. But if you go to a multiple choice question, or a multiple choice answer, sorry, they won't put the 0. Because 0 plus something or 0 minus something does nothing, right? So what they'll write is they'll just go pi n NEI. If your principal angle, your first angle is 0, they just won't write it. Okay? Bless you. We're going to flip over to the coast graph. I want you to fill in all of these things. Amplitude, domain, y-intercept, period, range, and theta intercepts for the graph. What's different between the two? Where they start. Yeah. What else?
Y-intercept.
The y-intercept and the theta intercept. But my amplitude's still the same. It's 1. Because my max to my min is 2, which is half is 1. My domain is still theta ER. Oh, don't know why I did round bracket. I was putting the two types together. My range is still y such that -1 is less than or equal to y is less than or equal to 1 YER. Or in interval notation, -1 to 1. The period's still 2 pi. Because from a max to a max is a pi, is a period, not a pi. So it takes 2 pi to get there. The y-intercept in this case is at 0, 1. And these ones are pi over 2, 3 pi over 2, but it's still every, how much? Pi, correct? But the principal angle this time is not 0, it's pi over 2 plus pi n NEI. Okay, I want you to do something for me. Go to your calculators. So in your y1 you have sine x. In your y2 you have cos x. Go zoom trig. You only have to not do that when you're solving because you're going to do restricted domain. This is when I was going to say, hey, there's something called zoom trig, and you were all going to go, ah! But it was ruined. Spoiler. It's okay. I'll forgive you this time. Okay, you have it showing up?
Yes.
All right. Do you notice something about the two graphs? They look very similar, don't they? They look exactly the same, actually. Except what? Translated what? What kind of translation? Horizontal translation. Guess what? It's called the horizontal phase shift in trig. It's the only one. Only trig does it change to horizontal phase shift and vertical displacement for your transformations. But your stretches and reflections are all the same. You still find them all the same as well. So we're going to go sine x. We're going to go cos x. You guys have your calculators in degree mode from before, so I'm going to make sure mine's in degree mode. And then I'm going to go zoom. Make sure you pick the mode first before you zoom trig, because it zoom trigs it to whatever mode you're in. So if you go zoom trig, for example, 7, it's now in degree mode. We agree? Okay. Now if I go mode, actually I want it in radians, which would be really stupid, but say I do. And then I press graph, and then you call me over and you're all mad. You're like, it doesn't match. You get like super angry at me. Well, the window is actually from negative 495 radians now to 495 radians. Remember that 2 pi is 6. So a radian will repeat itself from 0 to like 6.2 something, right? I have it to 495. It's repeating a lot of times, correct? So now what I could do is I could go zoom trig again, and now it'll actually set my window to a nice radian one, because I'm in radian mode. So you have to pick the mode first before you zoom trig. If you zoom trig then mode, you just are undoing what you did. So I'm going to go back and put myself back in degrees, because that's where you're all sitting in. And I'm going to go zoom trig so that my window goes back to a degree window. Okay, so the blue one for me is the original. So I would, for my y2, I would make it a thicker line, just so if you don't have the colors, you can actually know which one is cos, correct? Also, you do know which one's cos, because cos starts at 0, 1. So I know the cos is actually the red one, and I know that sine starts at 0, 0, so it's the blue one. We agree? So let's think about this. I'm going to go to my little window. My window, I have every tick being 90. You see that? Every tick is 90. It made that for me. So if I want to take this red graph, which is the cos graph, do you see it? And I want to put it on top of the blue one. What am I going to have to do to it? If I want to take this red one, and I want to put it on top of the blue one, I'm going to have to move it to the right. How many? I'm going to move it 90 to the right, correct? So I'm going to go here, and how do I move it to the right? X minus 90. Yeah. I don't even want to know what you just did.
Well, can I see?
He's got like a spider you're looking at. Yeah.
Would it make a difference if you did a minus or not plus?
So if you go plus, watch what's going to happen. Shh. It's not going to be the right way. So could I, instead, paying attention, I have to subtract 90 to get the cos on top of the sine, right? But I could instead, delete, graph. I could instead move my blue on top of my red by subtracting it. So the blue, the sine, if I subtracted 90, like if I moved it to the left 90, I'm going to move my sine on top of my cos. But to move my cos on top of my sine, I have to move to the right. To move my sine on top of my cos, I have to move to the left. So if I go to my actual sine one, and I go x plus 90, then I would have the same ones, right? So all they are is a horizontal phase shift away from each other. That's all they are. Their amplitudes are the same. Their periods are the same. The only thing you saw that was different was the actual x-intercepts or the phase shift, right? To get them on top of each other. Okay? Over. We'll deal with those formulas in a second. We're going to look here. There are formulas above this. We're on example 1. There are formulas above it. But we're just going to look at these equations. So off of a graph, we could find the amplitude, we agreed, by finding half the distance from the max to the min. Yes? So we could have went absolute value of max minus min divided by 2, got our amplitude. The period, we just had to find the horizontal distance it took till it repeated itself. We agree? Off of a graph? But what is it off the equation? Well, let's think about it. Brain power. Nothing in your hands, no calculators, no pencils, no pens. I need every piece of brain power you've got. Okay? All of them. All that brain power. So let's look at this one. Let's look at this graph here. Okay? The amplitude is 1, we said, correct? What would be the only thing for a transformation, let's think in our heads. What would be the only thing that could make my amplitude grow or shrink? Yeah. Stretch. What stretch? Where do I find the vertical stretch? It's always the A value. It's always the one in front, very front. Correct? Is the vertical stretch ever negative? No. What does that negative do? It reflects it, doesn't it? It doesn't stretch it. It would just cause it to go down or up. So that wouldn't change my amplitude, would it? It would just make it reflect. So the min would come before the max would come before the min. Like that would be all that would happen. Now, transformations, horizontal movement, horizontal phase shift, is that going to change my amplitude? No. Is horizontal stretching going to? With the according it? No. So the only thing that's actually going to change my amplitude is my vertical stretch. We agree? Okay, we can pick our pens back up. So, our amplitude, ooh, that's an aggressively large marker. Our amplitude, I'm trying to sell it, but not that much selling. Our amplitude actually is equal to our vertical stretch, isn't it? Because when you start with a normal amplitude, a basic amplitude of 1, your vertical stretch is going to change it. Yeah? Yeah. Another way that they say the amplitude sometimes too is your amplitude just equals the absolute value of A. Because it can't be the negative sign, right? Because your amplitude's always positive. Because it's a distance. So if our amplitude is 1 and I throw a vertical stretch on it, it'll just be whatever it is, right? Because when you have an amplitude of 1, it just literally doubles it or halves it. So what's the amplitude of A? 2.
We have to recall an amplitude.
You will on a test. Because an amp is a standard of measurement.
So it would be 2 amps. No, because amps is.
Amps is an actual measurement, like meters.
What if you?
Not for the same thing. It's like volts. Amps.
Right. What if you have to write like amplitude or like vertical stretch on the diploma and you spell it wrong?
If we can sound it out, we're happy. If you wrote vertical stretch and it sounds like reading it horizontal stretch, it's not going to go. Okay?
So you could.
Or if like you're going to spell amplitude, but it actually spells period, no. Okay. What's the amplitude of this one? Half. Sam?
Did you use absolute value of A?
Yep. To show, no, like instead of the words?
Yeah.
No. So you can go amplitude equals the absolute value of a half and say it's a half. You can do that. But no matter what, you have to say amplitude or they don't know it's amplitude, right? And don't go by assumptions. If you ever say, I assume, stop. Don't do that. Okay? So, we have the amplitude. How do we get the period? Okay, talk about the period. The period of the graph is 2 pi. We agree? Both graphs, it was 2 pi. We agree? Okay, we need our big brains. We need to pay attention. So what's the only thing that could make our period shorter? Half, or widen, double, triple, quadruple? Horizontal stretch is the only one that would do that, correct? So, now, there's a formula for it, which we can use as well, or we can use horizontal stretch. So the formula for amplitude that we could use is absolute value of the A value, right? We could do that. The period, we can say, okay, if I take 2 pi and I multiply it by the horizontal stretch, which I can write HS because I'm not actually telling them it's the horizontal stretch, it's my notes, I will get the actual period, right? I can multiply by the horizontal stretch. Horizontal stretch can't be negative though, right? Because that would be the reflection. Okay, so let's talk about the period of this one. So the period of this one would be 2 pi multiplied by, what's my horizontal stretch? 1/3. So it would actually be 2 pi over 3. Correct? If you go to anyone else's notes who they don't go by transformations, they'll give you a formula. And I don't care if you use the formula. I don't care if you use horizontal stretch. I find if you use horizontal stretch, you make less mistakes because you just multiply by the horizontal stretch. Totally fine. You can use the formula. The formula is P equals, and it's above, it's written above, but we'll write it here anyways, 2 pi over B if it's in radians, or 360 degrees over the absolute value of B if it's in degrees. So this one here, I was going to say shiitake mushrooms, but you know, horizontal stretch. And it depends on what mode they give it to you in as to which one you pick. So if I go P equals 2 pi divided by the absolute value of B, what's B in this case? B is 3. B is what's there. So half of you will flip it and half of you will not flip it. You just use what it is because it's what B is. This is A, this is B, then we have C, then we have D, right? So B is 3, so it would be the absolute value of 3. So it would be 2 pi over 3. So it gets you the same answer if you use the formula. The problem lies is you guys not knowing if B is actually just B or if you put in the horizontal stretch, which you don't put in the horizontal stretch. You put in B if you use the formula. If you use horizontal stretch, you just multiply by it, which actually makes you multiply by 1/3 instead of dividing by 3. Okay?
Yes.
All right. For B, what's my period?
4 pi.
Yeah, because it's going to be 2 pi times the horizontal stretch, which is 2. So it's 4 pi. See, that was aggressive. I don't know why I did that. Okay, if you look at this table, all I want you to do for now is go through the whole table, and I want you to give me just the transformations. Remember, which doesn't happen here on this one, but remember for these ones, there aren't going to be any of these. These happen tomorrow, but and the next day. Horizontal phase shift is now going to be in for horizontal translation only for trig, and vertical displacement is in for vertical translation. We aren't using it today because I'm not asking you those, but what I want here on this little sheet is I want you to list the transformations and the mapping. Transformations and mapping. Move to the next one. So for example, this one would be vertical stretch by a factor of about the x-axis, and I would get xy becomes x 2y. Underneath each equation, I want you to give me the amplitude. And what else do you think I want you to give me? Period. So you're going to go through and do the whole chart. Not the whole chart, like, of it. The whole chart where you give me the transformations and the mapping, amplitude, period. Move on to the next one. So this amplitude would be 2. The period of this one would be 2 pi. Or 360 degrees. Give it in both. Degrees and radians. Try those out. Okay. We're going to go through the rest of the chart tomorrow. But for today, all you have is page 234. Yep. Can't see it. We have problems. 7 to 9. I am not joking. If you actually go to those, you would be done before you leave because it's like determine the amplitude. Determine the period.
We'll have these at home, it won't take me any time.